Hey, Vlad here, devinside.com. Welcome to another video. In the previous video, we learned about the basics of the set theory, just enough for us to get started implementing our own collections library. In this video, we're going to implement a very basic, very mathematical version of sets. We will be able to, we're obviously going to set up our project, and then we'll be able to add elements, remove elements, calculate the union, intersection, and the difference of sets. All right, let's not waste any more time and get started. Alright, as I already mentioned in the previous video, the amount of videos dedicated to the collections library might get kind of long. So the idea is that we will create a GitHub repository right now, and then I will try as hard as I can to create only one commit per video. So we're going to code the whole thing, and then by the end of the video, I'm going to create a commit and I'm going to push it. I might end up cleaning it up a little bit after that and creating yet another commit. I'm going to try, to do something with the naming so that you can clearly recognize that it still belongs to the same video. And then later you will be able to go to GitHub and to click on commits and to see exactly which change comes from which video. All right, let's do this. So new, and we're going to call it Homegrown Collections. Homegrown-collections. Right here, right now. All right, description, a collections library created specifically for educational purposes. Do not use in production. As I already mentioned, we're not going to optimize our collections library. So we're obviously gonna talk about algorithmic complexity, but still we're not gonna optimize anything. So do not use this in production. Use this only for educational purposes. All right. So initialize the repository with README. Yes, please. And get ignore. Yes, I'm gonna do a Scala project. Funnily enough, it doesn't add the target folder for the SBT, which we're gonna do. All right. So let's do the MIT. Actually, that's a library. Let's go with Apache. I think for libraries, Apache is more suitable. All right. So the cool thing about GitHub is, and by the way, I have a plugin here called Octotree. I'm gonna leave the link down in the description, which allows you to browse the whole folder structure over here as you would do in your editor. So one of the cool things about GitHub, I mean, this video is not about GitHub anyway, is that it allows you to change the files actually right here, right now. So the first thing that we're gonna do is we're gonna go to git ignore. Even before we clone this repository, I'm gonna edit this file, and we're going to add the target/folder, which is the default folder, actually multiple subfolders, also called target, that SBT generates, and we don't want to commit them. We don't want Git to look at them at all. All right, so let's clone or download. Over here, I'm gonna download with SSH. You can also use HTTPS. Just click here, and it will switch to HTTPS. Click here, copy, and now I'm gonna go to my VM. I'm gonna open a terminal, which I'm gonna position on the right like this. I'm gonna go to the folder called dev, and if you don't have Git installed, I actually have a video showing how to set up Ubuntu, how to set up all these tools. If you're in Windows, just go to the Google Windows Git and just click through the installer. It's very, very simple. So I already have Git installed, but if I try to install it again like this, it's just going to say that it's already installed. So it says as your upgrade 0 newly installed, 0 to remove, and 11 not upgraded, whatever that means. All right, so I'm just going to say git clone, and then I'm going to paste whatever I copied from Git. So now it's going to ask me to unlock my private key because I'm using SSH. All right, and that worked. And now I can go into this folder, Homegrown Collections, which is over here, right? And I could start SBT in it. Actually, let me press Control-L so that you see. And I'm using ZSH, which is an alternative shell. It's an alternative to Bash, and it already shows me that it understands Git, so it shows me that I'm on the master branch, right? So I'm gonna try not to use the terminal so much, at least for this. I'm gonna go to dev Homegrown Collections, and I'm gonna open this with Sublime, even before we start SBT. Right, so Sublime opened up 2 times. It opened the previous one and the new one. The new one is this one, Untitled Homegrown Collections. Now I can close that. Let's put Sublime on the left. Let's press Ctrl-KB so that it shows me the folder. And we see our README file, which is a markdown file. We see the license that GitHub generated, Apache license. And we see our gitignore file, which contains target/. So the first thing that we're going to do is we're going to create a folder called project. All right, and inside of project, we're going to create a file called build properties. And in build properties, the only thing we need to do is we need to specify the version, which is going to be 0.13.6. Now, by now, the latest SBT version is 1.12 or something, and by the time you're watching this video, it's going to be even higher. But this entire playlist, I have been using this, and I'm still happy with this one. So we're going to stick to what works, right? The next thing that we're going to create is, actually, let me open this. So we have our build properties over there. The next thing that we're going to create is another file called plugins SBT, and it doesn't matter how it is called. It just has to be in this folder, and it has to have the extension of SBT. And we're going to use 2 plugins for our project. The first plugin is going to be, actually, let me copy paste it. I don't want to waste your time. I'm going to paste it over here, and I'm going to set up my Sublime to wrap the lines. So I think if I go to edit, wrap, nope, view, word wrap, probably like this. Yeah, okay, so as you can see, I still have only 3 lines, and the 4th one is empty, but at least Sublime wraps it in such a way that you can see everything, right? So if I maximize Sublime, you see that it's actually 2 lines, but it's just wrapped so that you can see all of the code, so that I don't have to scroll horizontally. So the first plugin that we're going to use is going to be called scalariform, and this is the link, which I'm going to also leave down in the description. And what it will do, it will automatically format our code, right? So it will make sure that it's properly indented and so on. I'll show you it later. And the cool thing about it is that it is fully integrated into SBT, right? It's a plugin, so it is integrated into the compile task. So every time we're going to recompile our code, it will also format it, right? And the other plugin is the one that I already introduced in the 2 videos before, called scoverage, which probably stands for Scala coverage, which is for to showing the percentage of the code that is covered by your test, right? Okay, so this is plugins.sbt, and the next file that we're going to create is actually going to be the build SBT file, which is not going to be in project. It's going to be in the root over here, new file. We're starting completely from scratch, right? So it's going to be called build.sbt, and as always, it doesn't matter how it's called. It just has to be in this folder, this particular one, and the extension has to be SBT. Okay, so the version is going to be 0.01. Let's actually make it a snapshot because it's still in progress. Organization is going to be dev inside you. All right. And Scala version is going to be 2.12. By now 2.12.6 is out, but we have been using 2.12.4 all the time, so the same as with SBT, we're going to stick to that. The next one is triggered message watched clear when triggered. And what this one will do is, this is the one that we have been using all the time. So whenever we use continuous compilation or continuous running or continuous running of tests, basically continuous execution, what will happen is that SBT will clear the screen, right? So this is not even SBT, this is just a regular terminal. If I press enter a few times and I press Control L, it will actually clear the screen, right? So it will basically scroll down. So SBT will do this for us automatically. The next thing that we're going to do is we're going to add an initial commands in console, just in console, import homegrown dot collections underscore, right? So what this will do is, and by the way, why didn't it, hold up, view word wrap. Oh, is this per file? Oh, that kind of sucks. Okay, hold up, let me look it up in the settings. It's gonna take forever. I'm gonna cut it out. Hold up, word wrap, just wrap. Okay, hold up, word wrap automatic. All right, so again, initial commands in console, import homegrown collections. This will make sure that once we're inside of SBT and then we start the console just to play around with our collections, the first thing that will happen is this thing, right? It will automatically import homegrown collections underscore, which is going to be our package, okay? The next thing that we're going to do is we're going to add this alias. It's the same alias that I created like 2 videos ago when I introduced the scoverage plugin. So every time I'm going to type in test C, what it will actually do is it will clean the entire project, and then it will run the coverage command, and then it will run the test, and then it will generate the coverage report. All right, like this. Okay, and we're going to add a library dependency just for the tests, right? Because we're going to write a lot of tests. By the end of the part of the collections library that is where we talk only about sets, just for sets alone, we're going to have 5 times as much tests as production code. All right, so I don't think that we will add more than one library, but still, just to make it this future-proof, let's add Scala test. I already have made a video about Scala test, and the version is going to be 3.05, 3.0.5. and we're adding this only to the test scope, right, like that. And the website is HTTP, not HTTPS, by the way. I'm wondering why. All right, and that's all we need for build SBT. Now, the last thing that we actually sort of do need for SBT configuration is sort of optional, but scalariform allows you to choose how you want to format your code, right? So there are many settings, and because there are many settings, we're actually not going to add them here. Remember that I always have been saying that it doesn't really matter how you call your file; it just has to have the extension of SBT. Well, it turns out that it also doesn't matter how many files you have there, right? So we can create a separate file, because I don't want to pollute this file with scalariform settings, because there's going to be a lot of them. In fact, I'm going to copy paste them. So what we're going to do is we're going to create another file, and I'm going to call it scalariform. I'm going to have some rendering issues over here. Scalariform.sbt, right? It's going to be in the same folder as build.sbt. It should be. Yeah, it's just that it's sorted a little bit weirdly. And what I'm going to do here is I'm going to paste that, all of these settings that I want to have, right? So we're importing. Again, let me turn on word wrap. In fact, for this one, I'm just going to maximize Sublime so that you can see. So all we're doing is we're importing Scalariform formatter preferences, because remember that all the build configurations for SBT is actually Scala code, right? So all of this is Scala code, right? And all we're doing is basically all I did was I just selected all the settings from the website. Again, I'm going to leave the link down in the description, and I just turned the ones that I care about to true. Right, so for example, align arguments, align single line case statements, and so on and so on and so on. All right, so this should be enough. So let's actually, we can already start SBT. I mean, we could have done it even before, but we would have ended up, restarting it. So let's just start SBT and see if we did any mistakes in the build file. Looks all right. Loading stuff. Okay, set current project. All right, so let's do compile. I mean, there's nothing to compile right now, but still. All right, unresolved dependencies, Scala tests. Okay, so there's probably a typo somewhere. Let's go to, no, not plugins, build SBT. Come on, what's up with my rendering issues today? All right, so it's Oracle. Oh yeah, here I forgot one of these. So this thing will add underscore 212, right? Because we're using Scala 12. So when I use this, I don't have to do that explicitly, right? So it will happen for me. All right, so let me press Control L inside of SBT so that my face doesn't cover everything, and let's reload the build file, and let's try to compile. All right, let's try to test. It should say that there are no tests around. And by the way, you didn't see SBT downloading Scala test because I already have it, okay? And the last thing that we're gonna do is we're gonna run console, and it should explode because we don't have the package yet. Yeah, see, so it says not found value homegrown collections. Let me press enter a few times so that you actually see it. It says not found value homegrown because we haven't created this file yet, okay, this package yet. All right, so let's go here and create a new folder, and it's going to be source main Scala, and let's create another one called source test Scala. In fact, we should have created a folder called Homegrown in there probably. Should we do that? Yeah, we probably should. All right, so let's go to source main Scala, and let me actually open test Scala as well. Let me create another folder here called Homegrown. Yeah, actually, okay. Let's create. I just this is an old convention, and now our tree becomes unnecessarily large, right? So we're gonna have like basically everything inside of this collections folder. So there's actually no need to have it. But let's just stick to the book. Let's do everything by the book. Okay, let's do a new folder over here in the test. We're going to maintain exactly the same structure in our test. In fact, you know what? Maybe we shouldn't do this in our test. No, we should. So okay, so we're gonna maintain the same folder structure, but we're not gonna maintain the same package structure. Okay, so let's do homegrown collections, right? So over here, we're going to create a new file, and we're going to call it set because we're implementing the sets today, and the package is going to be homegrown.collections, right? And let me actually copy that. And over here, we're going to create a file called set suite, right? And instead of doing package, we're going to import it, right? Because I want to mimic as much as possible our users, right? So our users, they will have our library on the class path, and they will import it. They will not like participate, sort of. They will not be part of this package. So they will import it. So I want to reproduce the real environment as much as possible in my test, right? Okay, so I saved the file, everything is fine. So if I exit the console, let me press Control L again. Okay, let me go to console again. Sorry, what happened? Oh, well, we're not even in SBT. Oh, the entire SBT crashed because of that? That's interesting. All right, so console. Now it should be fine because as of right now, we at least have the package. All right, maybe that's not enough because we don't even have anything over here, right? So we can just have a package. Let's just create an object set. Okay. All right. So let's do console. Oh, whoops. Console like that. All right. This time it actually worked. Okay, so let me exit the console now, press Control L, and all we're going to do today is we're going to get stuck in the continuous test execution. So today we're going to practice a lot of test-driven development. Actually, let me press Ctrl-K-B. We don't need the tree anymore, and we actually don't need all of these files. So we will only need set, and we will only need the set suite. Let me close the tabs to the right, and let me also split Sublime into 2 panes like this. And we're going to have the set at the top, and the set suite, we're going to have it at the bottom, right? So the set suite is going to be here, and the sets is going to be over there. So what we're going to do is we're going to import org Scala test, everything in there, and we're going to create a class set suite, which extends fun suite with matchers. If you need the Scala test, maybe you might want to rewatch the video about it, right? So, but basically the way Scala test works is that you extend a few traits like this, and it has a current function called test, because it's current, it has multiple parameter list. In this case, it's 2. The first one wants a string with the name of the test, some name, and over here you basically run your code, right? So for example, you can say 1 should be 1, and the test should be green. It's going to say set suite, this is the name of the test, and it's green. And if I do 1 should be 2, then it's going to be red. And that's all you need basically to know about Scala test for now, right? So one thing that you need to know about test-driven development is that the order in which you write the test matters, and you'll sort of learn about it once you gain a bit of experience. But basically, the secret is never to go for the gold, right? So, for example, what is the essence of sets? Well, the most important functionality of a set is basically to figure out, does the element belong to the set or not, right? So is it an element of the set or not? So one natural way to model sets, or the way programmers say is to encode sets, is to basically encode them as a function, right? Which takes the element and returns you a Boolean, which it says, is the element inside or not, right? So if you start with this, right? So if we start with if you go for the goal, basically, it will basically be almost impossible to write a test that will make sense, right? But we'll still try, just to demonstrate them. So the first test we're gonna try to write is that if you have an empty set, then whatever you ask it, whatever element you will give it to ask it if it's inside or not, it will always say false, right? And you will see in a second that it's actually kind of impossible to write this test, but we'll still try, right? So we're gonna say apply on an empty set, right, should yield false. This is going to be the name of our test, and if I save it, it's going to be green because there's no code over there, but at least the name is going to be right. Okay, so We have this object set over here, right? Because I sort of knew that we're gonna end up having it, right? So what we want to do is something like set.empty. So this is how I want to be able to create sets, right? So, and the test-driven development basic says, you know, write a little bit of test, but just enough so that you know, you can cause the test to fail, and not compiling is failing, right? So if I try to compile this now, it's gonna say, okay, empty is not defined on set, right? So we could do that already. So we can go over here and we can say val empty, you know, which is, as I said, we're going to model sets as functions which take the element, and in our case we're gonna work with only strings, right? So we're only gonna work with sets of strings, right? So it's going to be a function that takes a string and produces a boolean, right? This function. And for now, let's not implement it, right? So because for now all we care about is that it compiles, right? So now it compiles, but it throws this exception, this one. This is just a def defined somewhere in Scala, and specifically in the pre-def object, which just throws a not implemented error, right? Okay, but still, let's continue. So set.empty, and now we want to ask it that whatever element we're going to give you, you should answer false, right? So this is set.empty is a function, right? So if you give it any element, and we're going to give it some random element, then whatever comes back should be false. Now let's implement real quick a tiny private def, which will help us out with generation of random elements, right? So it will just generate a string for us because, you know, as I said, we're going to work only with strings today, and it's going to go to a Scala util random because everything random begins with Scala util random, right? And there's so random is an object, and it has a function. It has a def called alphanumeric, which is going to be absolutely fine for our purposes. And alphanumeric gives you a stream, right? A stream of characters, like as many as you want. It's sort of like an infinite stream. We're going to talk about streams a bit later in, I don't know, like 10 videos from now on or so, right? And you can just take a few elements from that string. So all the tests that we're going to write today, they will work with this random element. Let's actually call it random string, random string, right? And all of them will have 5 elements. So the type of this is stream of characters, and it's going to be 5 characters long. So all we need to do is we need to actually convert it to a string, right? Like this. Okay, so this is our first test, and everything compiles, but it still throws the not implemented error. Now it's easy to implement this test, right? Because all we need to do is we need to say, okay, well, whatever comes in, right? Whatever input comes in, just return false, right? In fact, we don't even need, you know, to use the word input here because we're not using it on the right hand side, so we actually could have an underscore here, but I'm still going to stick to using input. Okay, so now you sort of see that this test is sort of meaningless, and this is also one of the things that you need to know about libraries. Usually when you write libraries, especially when you write them in Scala, and you know, Scala people will love functional programming, every time you write something functional, which means every time you write something that doesn't have internal state, because our sets are not going to have internal state. Every time we're going to add an element, we're actually going to produce an entirely new set. What you should be writing probably are not unit tests, but property-based tests. And property-based tests, basically they generate tests for you. So at least for this one, if we were using property-based tests, then this one test would actually generate hundreds of tests and run them. We're sort of mimicking this with random strings, right? So we could sort of do this ourselves, right? We could say, okay, so let's just do 1 to, I don't know, 1000, right? So this is a range. And then we can say for each, and for each element of this range, which we don't care about, we're going to run this test, right? So usually, you know, you will have a property-based testing library like Scala check, for example, that will help you do something like this, which is going to be like way more convenient than what I just did. So this, everything over here is for educational purposes, right? So we don't really care about that. This should be enough for us. And as I said, when you do test-driven development, the first test you write, don't go for the gold. Go for, you know, exceptional things. You know, for example, a typical things for sets would be to say, okay, an empty set, you know, the first test would be an empty set should have a size 0, right? But in our case, we're going to implement the mathematical version of sets, and we're not even going to have the function called size, at least not in this video, and maybe not even not in the next one, right? Because for us, a set is just a function, and the function doesn't have a size. All right, let's continue with the next test. So what is the next sort of dumbest test that we could write, because this is how you do test-driven development. You know, you want to write like the smallest possible, you know, you want to go like, you want to take like the smallest possible steps, you know, baby steps all the time. So I think we should be able to add elements to the set. I have no idea how we're going to test it, but let's at least try it. So add on an empty set, right? So we're going to start with an empty set because this is all we got so far. Should yield a new set with one element. And I still don't understand why word wrapping doesn't work. All right, so let's do view word wrap. Didn't work. View word wrap. What's happening? All right, there we go. So the name of the task is now wrap. All right. So what we're going to do is we're going to have a first element, which is going to be a random string, right? We're going to have a second element, which is going to be a random string, and we're going to say first should not be second, just to make sure that whatever is generated is, you know, not the same thing. Okay, so now we're going to create a set by saying set.empty. This is all we have, and what we want to have is we want to have a function called add, right? So we want to be able to add the first element, right? And then we want to call the function, right? So we want to say set of first, which basically asking the set is first part of you, right? Is first element of you, right? And it should be true. And if we ask it if the second element is in there, it should say false, right? Which is, you know, sort of not an ideal test, but, you know, it's better than nothing. All right. So now it should tell us, okay, add is not a member of function string to boolean. So now we need a bigger boat. So just having a function is not enough. So what we're going to do is we're going to have a trait over here. I'm going to have a trait set, and this object is going to be the companion of that. Now this trait set is going to extend this function, right? So we're going to cut this out, paste it over here, copy that, paste it over here, right? Like this. So now this is a trait, so this is our thing, and we can do whatever we want in there. So we're going to have a final def add, right? Which takes some input, which is a string, right? And what it should produce is a completely different set, right? Remember, we're doing the completely immutable thing, right? So we're not changing the set in place. There's no internal state. We're creating an entirely new set, okay? And for now, let's just throw an exception. All right, so everything works in the sense of it compiles, right? It compiles, but it still throws this exception. Now, the first thing is, why does it compile? Like, first of all, you know, this is already a lot of syntax. For example, how did this ended up being this? And this is what is called a SAM type, what is it called? Optimization or something like that? No, it's probably not optimization. SAM type, let's say generation. So set, you know, this trait, set, because it extends, you know, function one, and function one has only one method called apply, right? So there is only one abstract method in the trait set, and therefore Scala will help us out. It will say, okay, so if you give me a function which matches the signature, I'm going to create a set for you. So what is happening over here is something like this: new set, override final def apply, which takes some input string, right, equals false, right? So this function is now over here, and we should have exactly the same result. I mean, usually you refactor code when your tests are green, but in this case, you know, I'm just showing you. In fact, let's leave it like this for a bit, and then we'll go back to that. Okay, now this is going to be a bit complicated especially if you're not used to functional code. Basically, what we're going to abuse here, not abuse, we're actually going to make full use of the environment model of computation. So we're going to end up having those sets sort of trapping inside this element that we're talking about. So we're going to use the same trick over here, right? So this thing has to give us a function back, right? So a set is essentially a function where an element comes in and a boolean comes out, right? So in this line, somehow we need to generate a boolean, right? So if I say false here, at least it's going to compile, you know. If I say true here, at least it's going to compile, right? So whatever we do here is, you know, we need to return a function that takes a string, produces some boolean, and this is what is happening here. So now we just need to implement it correctly. Now, how can we return true here? So this is presumably a set that contains an element, right? So we have the input and we have the element. So let's see if they are the same, right? So if input equals element, let's see. Wow, that is already cool. That is already working. I didn't know that it would be so simple. Well, this is what you get from test-driven development. You know, sometimes you write a teeny bit of code and you think that, you know, that you actually need more code, but it turns out that this is enough because our tests are dumb. You know, they go like baby, you know, they do baby steps. So let's just write the next one, and the next one is going to be, and by the way, I know that I'm going like super slow, but we're gonna keep increasing the pace, and at some point it's gonna get actually kind of fast. All right, so let's do another one. Let's do add on a non-empty set should yield a new set with 2 elements, right? So let's do the same thing. Let's do first equals random string. Let's do second equals random string, right? And let me scroll down a little bit over here, right? So let's do the same thing. First should not be second. And let's create a set again. Set dot empty dot add. Let's add the first one and call add again and add the second one, because remember, add gives us a new set. So this is a set, this is a set, this is a set, right? So we can just keep calling add, and what will end up being created is different sets. Okay, so we're adding both of them now, and now set of first should be true, and set of second should be true, and this test should fail. But if I remove the second one, then it should pass, because this is essentially the same test as before. What is happening? Did I not save it? Oh yeah, hold up. I need to comment out this one. Right? It's kind of weird because this element was added last, and therefore it is this one. Right? So yeah. So how do we do this? And this is going to be a little bit hard to grasp. Like even when I was implemented like this, I was like, how does it work again? So play around with this on your own. Again, we're gonna commit this whole thing to GitHub. Clone it, play around with this. So what we're gonna say is, okay, so this is basically the last element or the first element. Remember, sets don't have an order. So this is basically whatever the first element is. If it is not equal to whatever is being passed over here, then we need to keep going, right? Then we need to say or, and now we need to call the apply function, so we can do just this, and we just need to pass to keep passing the element, right? So this one. Okay, so let's see, and now it's green. Now I know that this is sort of hard to understand, but basically we're digging down to all the functions, right? Because every time we're adding an element to a set, we're actually creating a new function from string to boolean, which inside of it sort of has access to the previous function string to boolean, and this one has access to the previous function string to boolean all the way down until it ends up here in the empty version of it. And by the way, I think by now this is enough with this. Let's just remove that. Let's have this one. All right, everything is green. All right, so we're done with adding things. This is actually the final implementation. Let's write a test for removal. All right, so we're gonna have a test, and it's going to be called remove on a non-empty set should yield a yield. All right, a new set without the element, right? And the implementation is going to be like this. So we're going to have an element, right, which is going to be a random string. Okay, and we're going to say we're going to have a set with element, which is going to be set.empty.add element, right? So we need to add an element first. This is why we implemented the add function first and made sure that it actually works. Okay, so now we're going to create a, actually before we're going to create the next one, let's ask the set with element if the element is actually inside. It should be true, right? Just to make sure. Okay, and now we're going to have a set without the element, and we're going to say set with element remove, that we don't have yet, remove the element, right? So now after that, this new set without element, if we pass in the element, whoops, it should say false, right? So remove obviously doesn't exist yet, but remove, what remove will do is hold up, recursive value set without, what is happening with element, without element. Oh, here, this should say with. All right, there we go. All right, so this is the correct error message. Value remove is not a member. Okay, so the way removal works is, again, it will produce a completely different set that doesn't have this element, right? So the old set, the set with element will remain intact. This is why we're doing this thing, right? We're producing an entirely new set, assigning it to set without element, and then we're talking to that one, right? So after that, like this line, it still should be true. It's still the same set, okay? I'm actually gonna leave this line there for a while. Okay, now because remove is essentially sort of reverse of add, it's going to have exactly the same signature. So I'm going to actually duplicate this line, and I'm going to say remove over here, remove, okay? And now we're basically going to reverse it, right? So we're going to say, okay, if input is not element, and let's see if that's already enough. It should be, because it's only one element, right? So it's basically, well, if input is not element, then it doesn't contain this element. And we're going to have the same situation with the next test. So if we're going to add the next test, which adds actually 2 elements and then removes 1, let's do that. And by the way, remember, this line was still true. I'm going to remove it now, but it worked. So the old set remained intact. All right, so remove removes only the element in question, right? So we're going to have, again, val first equals random string. I'm going to have val second equals random string, and we're going to have set with element as before equals set.empty.add first dot add second, and now we're going to go like this. Let me scroll down a little bit. All right, so we're going to go set with element first should be true. Let me duplicate that line. The same thing should happen for the second one. All right, so now we're going to do the set without element, this one. I'm going to do the same thing as before, set with element dot remove first. All right, so, and now let's work with this one that was with element, was the one that without element. We're going to ask the first one should be false, and actually let me duplicate that line like this, go over here. Second one should be true. All right, and this one should fail. And basically what we need to do over here is, again, we're basically inverting everything, right? So we're going to say not, and then the same thing, right? So this is how you remove things. And I know that it kind of takes some time to wrap your head around this. You really need to play with this. What I want to do now is actually, I don't have this in my preparation, but I think I want to do this in reverse as well. So I'm going to copy paste the entire test. I'm going to call it 2. And what I'm going to do here is I'm not going to remove the first one. I'm going to remove the second one, right? So now this one should be true and this one should be false. And let's see if this still works. And I hope that it does, and it does. It's still green. All right, we're actually done with adding and removal, which is kind of exciting because we could actually wrap up the video over here, but we're actually going to finish it with with union, difference, and intersection. So let's start with union, and again the same thing, like going for the gold. It's sort of weird, right? So union on an empty set should yield an empty set. Remember, union is basically taking the elements of both sets, right? There are no conditions and there is no filtering, just take all of them together and that's it, right? So it's essentially a logical OR, okay? So we're going to do set empty union, and union takes it as a parameter, not an element, but it takes another set, right? So we do set.empty, right? And then, so this produces a set, right? So we can ask it if it contains a random string, right? And we expect it to give us false back, right? So as of right now, this function is not even defined. So let's actually define it. Now we're not going to copy paste this because the signature is a little bit different. So we're going to do union, and the input is going to be another set, right? So this one is called this, and the other one we're going to call it that. This is just a convention. This is not a keyword. I read a question recently on Stack Overflow, I believe, somebody asking like, what does that keyword do? This is not a keyword. We're just calling this variable that. This one actually is a keyword which always refers to the environment that we're in, right? So it always refers to the set. To this set. Okay, so as always, it produces another set, right? So it's basically union of 2 sets, okay? And we're going to generate a set the same way as before. As of right now, I'm just going to say false, so that the test, yeah, okay. Something goes crazy with type classes. Wow, okay. This is insane. All right, just ignore all of that. I just wanted, the test to fail, but like, not like that. Sure, return true. Why doesn't this work? It should compile. What is happening? Oh yeah, oh, it's a should. Oh, it's totally my fault. I'm sorry. Should be false. All right, so true, false. Now the tests are happy. Let's just keep going with the next one, because I don't want this video to be longer than 1 hour, and this is the first video, so we have to cover a lot of ground. All right, so union on a non-empty set with an empty set should yield the original set untouched, right? So if we take an element, a set with a few elements, and we just calculate the union with an empty set, then the set should be untouched. Okay, so we're gonna have a first, as always, random string. We're gonna have a second, as always, random string, and we're gonna have first should not be second. And let me scroll down a little bit. In fact, let me do this. Like as long as we're writing tests, I'm gonna do this. All right. So I'm actually gonna make sure that you still see at least the remove function. Okay, like this. Maybe also the union. Let's do it like this. So now you see everything. All right. So we're gonna have an empty set. Actually, we're gonna store it into a variable. Not that we have to, but just for readability purposes. Okay. So we're gonna have a non-empty set as well, where we're gonna take the empty set. Right. Gonna add both of these elements. Add first. Add second. By the way, by the end of this collections library, our tasks are going to be refactored many times, because we're going to have like a way better, a better way to create sets, a better way to compare sets, and so on and so on and so on. But for now, we're just starting out. Okay, so let's do empty set union non-empty set, and let's ask it if it contains the first element, and it should be true. Should be true. And let's do the same thing for the second one. Right. And let's do the same thing now in reverse. So non-empty set union empty set. Okay, does it contain the first one? Should be true. Duplicate that. Does it contain the second one? Should be true. All of this should be true, right? So basically it should be exactly the same set as we put it, right? And the implementation for union is basically we're going to ask the current set if it contains the element, right? This element, or, because remember, union is just an or if that one actually contains the element. Let's see. And that's it. It's already green. All right. So this is the final implementation, but let's just for visibility purposes, actually add a task that combines actually real sets. Okay. So real sets means non-empty sets. Okay. So union on two non-empty sets should yield, well, their union. Okay, so let's go over here, and we're gonna have a bunch of strings. So we're gonna have A, B, C, D, B, C, and D. Now we're gonna have to create two sets. We're gonna create a left set where we're gonna add only A and B, and we're gonna have the right set. Not that the left or right, the order doesn't really matter, because union is a commutative operation, so the order doesn't matter in this case. Okay, so let's calculate the union. Left union right. And again, because union is a commutative operation, so left union right and right union left should be exactly the same thing. Okay, so we're going to ask union of A should be true, right? And all of these basically, I think I can copy them like this and insert them like that, right? So everything should be true, right? This test is kind of silly. So we have the saying, never trust a set that you have, never trust a test that you haven't seen fail, right? So this test, it has never been read, because we're basically already done, right? Because this is the entire implementation. Okay, so let's do intersection. Intersection is going to be very, very similar. The implementation is also going to look very, very similar. We're just going to have an and over here, right? All right, so let's do the same trick as before. Intersection on empty set should yield an empty set. Okay, so we're just going to do that. Set.empty. In fact, you know what we can do is we can go up, and I can duplicate this code, right? Just gonna go down, I duplicate this line and I just brought it down. So now all we need to do is, instead of union, we need to say intersection, right? And it still should be false, right? Now it's not gonna compile because intersection is not defined. So because I already know the exact implementation and I already told you it's gonna be very, very symmetrical, I can literally copy paste that, and I wanna save you some time, right? So intersection is gonna be exactly the same, but it's gonna be an and over here. right? So now it's going to be sort of boring because all the tests that we're going to write now are actually going to pass, right? But still, let's write them out real quick. It's not that much. Intersection on a non-empty set with an empty set should yield an empty set. Okay. Sometimes I spell set small and sometimes with a capital one. It doesn't really matter. All right. So essentially, we can do the same thing. We can go to this one that was doing the same thing for the union, right? I'm gonna copy that. Gonna paste it over here, right? Now, everywhere it says union, we're gonna say intersection, and everywhere it says true, we're gonna say false. And I hope that I did it right. Yeah, it's green. Cool. All right, the next one is going to be, because as you can see, if the implementation is very symmetrical, then the tests are going to be also very, very symmetrical. I mean, they have to be. The last one is going to be the same as for the union. So intersection on two non-empty sets should yield their intersection. All right. Now, intersection is going to be a bit more fun. So when we copy that and bring it down over here, now everywhere we say union, we're going to say intersection. All right. Now, the intersection means that the element in both that are in both sets, only those will be considered. So for that, we're going to add B and C to both of them, right? So we're going to do add A, B, and C also. And for this one, we're going to add B and only then C. Again, the order doesn't really matter, but still just for readability purposes, I'm going to do, A, B, C, B, C, and D. So B, C should be the intersection, okay? So A should not be there, B should be there, C should be there, D should not be there. And there we go, it's still green. All right, the last one, the last couple that we're going to write are going to be the one for the difference test. Difference on empty set. Let me scroll down again. I don't have that much space here, okay? Should yield an empty set, right? Okay. So as always, let's go up. Copy that one. Bring it down over here. Let's do the difference. We could call it diff, but I'm going to keep calling it difference, right? So the difference should obviously also be false, and let's see if it compiles. And obviously it's not going to compile. The signature is going to be very, very similar as intersection, right? Over here, and the only difference is going to be, remember, the difference means it has to be in the current set, and it is not allowed to be in the other one, right? This is the difference. And over this, in this one, by the way, the order matters, right? So it's not going to be the same if we're going to do it like that, right? It's not going to be the same. I mean, for this test, it will be the same, but for the other test, it won't. Actually, we'll have a special test that makes sure that tested both sides, because difference is not a commutative operation. Okay, so the next one is going to be test difference on a non-empty set with an empty set should yield an empty set. All right, like this. All right, so let's copy the one for intersection, which is this one. Paste it over here. Now everywhere we say intersection, we're going to say difference. Diff tab. All right, so for difference means that an empty set difference with a non-empty set should be false, right? Because it doesn't contain the first element and it doesn't contain the second element, because none of them were contained in the non-empty set in the first place. Yeah, exactly. But the other way around, it should be true, right? It should be true over here, right? Because they were in the non-empty set to begin with. And if you calculate the difference with an empty set, then you give back a set with only the elements that were contained in the non-empty set, but not in the empty set. And there's nothing in the empty set, right? So whatever we do over here, it's going to say true. Okay, the last one is actually going to be the most exciting test, because we're going to do it, we're going to test it both ways. Okay, so we're going to do a difference on two non-empty sets should yield their, well, difference like this. Okay. All right, so this time we're gonna you know, copy a bit less. So we're going to, actually we're not gonna copy less, we're gonna copy this whole thing, right? So these ones are the same as for the intersection, right? So over here we're gonna call it difference, but in this case we need to distinguish between the left difference and between the right difference, right? So this one is going to be the left one, left difference like this, yes. And over here, LD tab left difference. All right, I hope I spelled difference right. All right, so for the left difference means that A, what's up with my rendering issues? Okay, so should A be in here? Right, it should be, because A is in the left one, but it is not in the right one, so it should be true. Everything else should be false. False, false, and false. Why? Okay, so let's start with an A again. So A is in the first one, but it is not in the second one, so it's true. B is in the first one, but it is also in the second one, right? C is in the first one, but it is in the second one. And D is not even in the first one, which is why it is also false, right? Remember, it's only the things that are in the left one, but are not in the right one. We don't care that the right one actually has more things, right? So it should be like this, and this should be green. Okay, and then we're going to do the other side. So we're going to do right difference equals right difference left. Okay, and let's copy these, paste them over here. Let me scroll down. Okay, so this is going to be right difference now, and the right difference should be symmetrically opposed, right? So well, sort of symmetrically, right? So this is going to be false. Right, but you're gonna do this the same way, right? So you're gonna ask, okay, so A was not even there in the right one to begin with, so it can't possibly yield true. B and C are in both of them, so it's also false. But D is the only interesting one. So D is only in the right one, but not in the left one. So it should be true, like this. All right, and that should still be green. So we're basically done for today, because in this first one I wanted to show you the mathematical version of the implementation of sets, and it's over here. Right, now these are not the only operations on sets which are mathematically defined, right? For example, something like is subset, right, should be defined on sets, but we actually can't implement it right now, right? Let's try. In fact, when you're doing test-driven development and you're developing alone, it's not such a bad idea to finish whatever you're doing with a task that is failing, because then you come back and you know exactly where you were, where you're going to start. So we're going to do is subset of, so this is going to be the function, is subset of, and when it is being called on an empty set, it should yield true, because an empty set is always a subset of every set, and also every set is a subset of itself. Right, so let's do set.empty is subset of set.empty should be true. And also let's add another one, just because, you know, we sort of can, is subset of set.empty dot add random string should also be true, right? Because as I already said, an empty set is a subset of every set. Right? Okay, so now it says that is subset of is not defined, so let's try to define it. So we're gonna go here, final def is subset of, right, of that set. And now this is the problem. Over here, what needs to come back is a Boolean, right? Because it's a Boolean, we don't have access to this element over here, right? It's just not there. All we have is the current set and the other set. But we have no way to touch every element. All of a sudden, we have no way to do that, right? Because over here, we're just producing an entirely new set, right? So we had access to the element. Everywhere over here, we had access to the element. But over here, we have no way how to go through all of them, right? And this is where we basically have to say false, or actually, let's actually, you know, throw in, you know, an implementation error like this. Right? Because I have actually no idea how to implement this in such encoding of the sets, which is why we're gonna redo the entire implementation of the sets in the next video, but we're not going to touch the tests. All the tests will still pass, right? They will still be green. They will not be touched. Not even a single character will be touched. All right. I got the idea for this video from the programming course that I took a long time ago. This course was hosted on the website called Coursera, and they're not sponsoring this, so I'm not getting any money for saying that. This course was from EPFL, which is the university where Martin Andersky was working at the time, and he's still working there. He's a professor there. This is the university basically where Scala was invented, and he himself was giving this course, and with the help of a few others, and it happened a long time ago, and they did basically this. So the course was called Introduction to Functional Programming in Scala, or something like this, or Functional Programming Principles in Scala. In fact, I actually have it open somewhere. Hold up. So what you see here is the Coursera website, and they have a concept of so-called specializations, where they basically take a bunch of courses and put them together. So by now, there are actually 5 different courses, and I'm not entirely sure, but I think every course is actually free. But if you're doing the specialization and you want the certificates, then you end up paying something. Don't take my word for it, though. Just go there and explore. So if we scroll down, I believe it's this one, Functional Programming Principles on Scala. Okay, Functional Programming Design, Parallel Programming, Big Data, Functional Programming Capstone. Okay, so this is the last one. Okay, so I believe it's this one, and I believe you can also choose to take this course only. So if you go there, one of the things that they do over there is to implement completely functional sets. So just as a recommendation, this is a very good course. It's very fundamental. It's very for beginners. But this is not an introduction to Scala. This is an introduction to functional programming, and they just do Scala sort of like on the buy side. Anyway, so what they did there was basically the same thing as we did over here, but they were using sets of integers, not of strings. And then when it came to implementing something like is subset of, they basically cheated. So they hard-coded a bound, which was 1,000 elements. And what they did is that this way they just tried every possible integer from negative bound to the positive bound, right? So the bound was 1,000. So they tried every integer from the negative 1,000 to the positive 1,000, and this is how they basically walked through all the integers. So they didn't even walk through every element of the set. They walked through the element of every basically every integer, sort of every integer, So we actually can't do this here, and this is why we will end up changing this entire implementation. In fact, it will happen 2 or 3 times, or maybe even 4, that we will rework the entire implementation, and we're not going to touch the tests, which is really cool. All right, so what I'm going to do now is I'm going to glimpse over it and see if I can fix a thing or two, and I will cut this part from the video, and then we're going to create the first commit, and we're going to push it. All right, so over here I sort of spontaneously decided to also test the commutativity of union. So let's go here and call this left union and put it over here, right? And let's do the same thing for the right union, because the result should be exactly the same, but we're actually not testing this, so let's test it. Copy that. Right union should be true. Actually makes it my sublime. Hold up like that. And oh yeah, we should probably ignore this last test. So we can just ignore it like that. Actually, we're technically not ignoring it. We're actually it's pending, right? So let's do pending like this. Okay, for Scala test it's the same effect, it's just that the message is going to be different over here, right? So let's do the same thing for the intersection. So we have, this is going to be the left intersection. Oops. Only this one, left intersection. All right, and let's do the same thing for the right intersection. Paste that. Basically, we're testing the commutativity, okay? And the difference, we already did the difference of, left and right. Okay, so I believe this is actually it. And by the way, I have a plugin for Sublime called VCS Gutter. So what it is doing is over here, it shows that every line here was edit. And once we actually commit, let's try to commit. Let's exit. Okay. So as you can see, my ZSH, my Z shell, also already tells me that there's something in there. Git status is going to show me, okay, all of this stuff is in there, and notice that the target folder is actually not there. So git add everything. Let's do git status, and now it's going to show me every file. So now if I scroll down by pressing enter a few times, you will see that actually now it shows more, because before it was only showing the folders, right? And now it actually shows each individual file. So today we created 1, 2, 3, 4, 5, 6 files. Okay. Let me press Control L. So git commit minus am. A stands for all the changes, and am stands for message. So let's say, okay, let's say video 1. It's not actually video, the first one, but you will know which one is the video 1. I'm gonna call it video one, and the way they called them in this programming course was functional sets, right? So they called it fun sets. I'm thinking if I should call it like this. Now let's just call it mathematical sets. No, let's call it sets as in math. Also, as you understand by now, I don't even know how I'm going to call this video, right? I'm going to probably call it something like this. Sets as in math, right? Let's say right here, commit, git status again. I mean, it already shows me that I should push it. All right, so let's push it. Some warnings, but it's actually pushing. There we go, it's pushed now. So if I go to GitHub, I reload the page. So now you see all the files over here. What you can do here, first of all, whenever you're going to look at this, because I'm buffering my videos, you're going to see like way more code here. So what you should do is you should go to the 3 commits, and then you're going to see, okay, this one, and then you can click on this one, and you're going to see exactly what changed. And over here, everything is green now. So you see all of this was just added, so nothing was changed. And if I go back to Sublime, as soon as I click over here, as soon as Sublime, gets focused, it will ask Git about this stuff, and all of these pluses will disappear. There you go. All right, that's it for today. I hope you're as excited about this entire playlist as me. Like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.